centrally with some box. Might be a wireless one, might be sort of, depends on when you sort of got it. Might be sort of wired connectors going to it. That's sort of got it's a similar system to what you've been dealing with in the lab. Lots of sensors, more than one sensor spread out around, actuators, whether it's a door lock or a light turning on, and then some sort of centralized processor for it. Where we're moving on to is this sort of Internet of Things and getting them all better networked together. This is all sold by one manufacturer, and the one manufacturer knows what the individual messages are that go to and from. It knows what type of message a sensor will send and how to turn on the light, and they'll have their own little protocol for that. When you start trying to integrate things from other manufacturers, so you get a camera from one manufacturer, a door locking system from another manufacturer, a lighting system from another manufacturer, and you're trying to get those all talking together, that gets a lot trickier to do because they've all got their own protocols. Potentially they might have their own boxes. Again, that little box that's going round, that controls the lights to it. And so I can talk to that direct, but you might have another box that talks to your locks, or another one that talks to the heating system, something like that. Now we can try and network these things together, and you can network them together just inside your own house and try and get them all talking to each other and have some sort of master controller. But expanding it out again, if you want to get to this from the outside, we'll have to connect them to some sort of server or cloud-based server somewhere to work with. Now that's the sort of thing that we're working on in the labs this week. Last week you looked at how to just make something like this, or the sort of other one, how to join some sensors and actuators together to read the data and sort of send it out. What we're looking at this week is how to take that data, send it off to a server, and then have somebody else connect to the server and drag that data back. And then later on we'll have a look at making our own protocols to talk to multiple ones. Because the idea being that yes, you're going to be sort of working with, say, outdoor environments, and in this case, say, the old driverless cars that are supposedly coming in. The cars that have got multiple sensors dotted about them, sensors for movement, for what's actually happening in the car, for the what gear you're in, whether the lights are on, movement outside, GPS for where it actually is, radars for detecting proximity of others. But also it's got to interact with devices around the street, like traffic lights, either doing that through a camera or perhaps reading information from a third party that's sending in information on what's happening in that sort of camera. So what we're sort of getting is more and more having to interact with sort of third party and thousands of sensors just within one device. As I say, a car has got that many potential sensors inside it. It's generating gigabytes of data every day to sort of process, both internally and possibly sending that out to servers somewhere so that your car can communicate with sort of traffic systems, finding out what the traffic is ahead. Any of you use Google Maps in the car? Hopefully you might have sort of seen that they do traffic analysis on the fly by if everybody's sort of got their location awareness turned on their phone, broadcasting the location, then you can sort of track where every single car is and what the average speed is, and then also detect when their average speed sort of slows down. So you can relate that to somebody back here and tell them that there's going to be a traffic jam ahead because they seem to be moving a lot slower. And then you're doing that in live time. And that's what all these sorts of in-car or on-person sensors are sort of leading on to sharing all that round and potentially helping out others. Doesn't always work. No, there's all these sort of problems either with Google ones or Tesla cars. I think one of the Tesla cars managed to kill a third party through a sort of, I think, a lorry driver. I can't remember if it was a driver or not, or whatever. So there's a lot of problems still around it, but you see only just in the in the news how all the manufacturers have announced that they're certainly doing electric cars, which is the next step to being all sort of driverless. And in 10 years' time, you're just going to be wondering why we drove in the first place, or something like that. That's the change coming. And we're going to be part of that, because we have to design these, this sort of similar module to this. We have to design all this Internet of Things, where potentially we've got something that's generating or collecting data from the physical space around us, sending that out to bringing all those components together and perhaps sort of controlling the physical world. So that might be, in the simplest case, reading an RFID one and turning a motor to open the door. It might be detecting movement in the road, applying the brakes on the car. Probably going through some sort of network to get those things together. It might be a local network, it might be a wider world network, if you like, going over the internet, perhaps some sort of cloud computing thrown in there. Somebody somewhere making a decision for it. Might have a human in the loop, which is always a dangerous thing, where somebody's making independent decisions, good or bad, thing around it. But that's the sort of system model that we're playing with. Now, just before we sort of dig down into that a bit more, it's a real multidisciplinary system using IoT. We're looking at it from a very technical point of view, but our department is constantly being approached by other departments who want to integrate Internet of Things into their own world, if you like. Currently, one of my biggest customers is the Fashion Institute. Just based over here. I mean, you think, what's fashion doing about the Internet of Things? They're doing all wearable devices. They're looking into sort of building the Internet of Things into wearable fabrics, making fabrics that can both sort of conduct and have washable processors embedded within it somewhere. They've just been working on a big contract with the Prisons Board to do things like prisoner tracking inside prisons. So it's built into their clothes and they know which sort of area that they're in. It does come into a lot of outside areas, but even within computing, there's a huge number of sub-areas, if you like, that it's going into, particularly things like machine learning and artificial intelligence. Anybody who's doing a bit of AI could well be interested in sort of doing bits of data mining and looking for patterns of behaviour in a lot of this data that we generate. For it. Robotics and control systems. HCI is a big area. It's how you interact with the outside world. So it's people designing those sorts of interfaces. Whole things to do with networks, wireless sensor networks, embedded systems, real-time systems. It's touching on all of these. And you'd have specialists in different sort of fields. So you can do Internet of Things related stuff and apply it to your artificial intelligence, or apply it to the front end of things, your computer interaction part. How do people interact with things that aren't screen-based? For example, we're a bit obsessed, really, in computer interaction with everything's got to have a screen. You do get the people, whether it's on the street or in the cafes, everywhere. I do it. We all do it. You sort of walking around looking at your phone, or people don't talk anymore, all that sort of thing, because they're too busy interacting with their phone. Everybody's obsessed with having some sort of screen all the time. And what we're trying to do in the human-computer interaction part of this is to more integrate it into everyday objects that you don't necessarily immediately see as being something that you're interacting with. For example, a pill bottle. You might sort of take medicines where the pill bottle has got a cap that glows different colours according to whether or not you should be taking your tablet. So like bright red when you should be actually taking it, green when you're sort of okay. You might have some sort of chip in to decide whether or not you're taking your medicine that day, and if not, to send a message off to somebody else to sort of say, your grandma hasn't taken her heart pills today or something, and it's now 2 hours late. Can you get there and tell them to do this sort of thing? So we can build alternative interactions into some of our devices, and that's what we're looking at in sort of one theme of it as well. So it's really quite multidisciplinary to work with. And from all these bits of the things that we're dealing with, sensing of data, the different ways of connectivity, and we'll be looking at all of these in our course, you can then look to apply them in other sort of areas. Yes, we will sort of look at some of these sort of applications, but essentially this course is looked at actually how do you make these things, and then you'll approach either perhaps in your project or somebody from another sort of discipline altogether to say, well, how do we make smart cities, smart parking, all these things about smart, and what do we mean by smart and the like. But smart devices, you throw smart in front of everything these days and it sells. Well, it's smart motorways they talk about. Originally we did just talk about smartphones, smart watches, smart clothing they have now, smart furniture, smart lights. Put that word smart in front of it and it seems to be the thing that sells it at the moment. And there's all these sort of technologies that we can't really live without for it. But what makes a smart thing, because that's the vision, if you like, of IoT, is to make an object smart. Well, whatever, or make a thing smart, whatever that thing happens to be, whether it's a phone, watch, TV, fridge, all those sorts of things.